Hello, and welcome to Chapter 3, Sections 2 and 3. This is all about energy, how it can change, but it's never created and it's never lost. So, we're going to start by just talking about changes. Now, we've talked about the big picture change from potential to kinetic, or vice versa, how you go from being on a high place to actually falling off that high place, that kind of thing. There's also other changes in energy, and they're a little more subtle sometimes, but they get converted into more usable or convenient forms. So when we start talking about changing energy, we have to start with the law of conservation of energy. And a law is not a theory, it's been absolutely proven and there's no question about it. And so this law of conservation of energy is that energy can neither be created nor destroyed. So you can't just like magically say, poof, here's some energy. It has to come from somewhere. And when you work energy on something, that energy goes somewhere and it does something. It doesn't just like poof disappear. There's no magic involved. It can be changed, but it's never really lost. For example, you push a box across the floor, okay? And let's say you put about 20 joules of energy into pushing this box. That's mechanical energy. That's you moving something. And if there's no other factors whatsoever, then that box moves with the force of 20 joules of energy. But that never happens because some of that energy moves the box, but some of the energy gets lost to friction. And some of the energy is lost to the noise that it makes as it scrapes across the floor. And some of that energy is lost if the floor is bumpy at all, concrete or gravel or whatever, as you're pushing it. Then there's other movements that's going on. It can be a vibration effect, but those movements take up some of your 20 joules of energy. So now you're only pushing with a force of 15 joules, or maybe only with 10 joules, but you still have to put in all 20 for this to happen. So it's the converting of energy that this section is all about. When you look at energy conversions, you want to create an efficient world. Energy efficiency means that almost all of the energy that you put in to doing the work goes to where it's supposed to. You want to push that box across the floor. You don't want to lose a bunch of energy to friction and rattling and noise and whatever. So if you can create a situation where the majority of the energy you put in is actually doing the work that you want it to, that's efficient. Okay? A measure of usable energy, how much energy is left over to actually do the work after you take off all of the stupid stuff after an energy conversion. Which means how much energy is being used to do what we want and not wasted with all the stupid other things. The largest use of energy on Earth is to produce light. So of all the energy electricity that we generate, we're all afraid of the dark. So that's the one that's the most important. Okay. An example of an efficient appliance. Let's use a fan, for example. If an efficient fan uses most of its energy to make the blades spin, because that's what a fan is supposed to do, is make the blades spin. So if you're putting all this energy into it and all that energy is being used to make the blade spin, it's a great fan. However, it becomes more inefficient the more things are going on. For example, if the motor rattles, then you've got this other movement that's happening, and so some of the energy that you're putting into your fan is going into the vibration, which is also mechanical energy. It's also movement energy, but it's not helping you get any cooler. So it's an inefficient use of your energy. If your motor makes any kind of noise, that's sound energy, and that comes out of the energy that you put in. If the motor gets hot, That's energy. That's thermal energy. And that comes from the energy that you put in. So the energy you put into it goes into doing a lot of other things too. And so the more efficient you can make it, the better off you are as far as the total amount of energy that you need to make something run. Okay? Now, we've spent a lot of years trying to make energy conversions better. When cars first came out, they were really noisy and they vibrated a lot and they were really hot and all that kind of stuff. And as the years went by, we made them more and more efficient. Light bulbs. Edison created the light bulb in the 1800s. They got really popular in the late 1800s, and we used the same basic model of light bulbs for like 100 years without even thinking twice about it. And the way a light bulb works, there's this little tiny wire, and you send the electricity through that wire. So the electricity comes in and just goes through the wire and it goes back out again and back into the plug, because you have to have a circuit for electricity. And all of that electricity going through that little itty bitty wire is too much for it. So it can't handle it, and so it starts to glow, like putting it in a fireplace, catching it on fire, that kind of thing. It starts to glow, and that glow, because of the specific metal used, that glow produces a really bright light. But that glow also produces a lot of heat. So really, light bulbs are really inefficient for the amount of heat that they give off. Have you ever had a light bulb on in your room and then it blows out and you have to change it and you can't touch it because it's so hot? That's why they created these new kind of light bulbs, the energy efficient light bulbs, the ones that they're a lot cooler to the touch. And it's not for convenience sake, it's because they don't want to waste all of that energy making all of that heat. Cars. An internal combustion engine works off of small explosions, repeated explosions. So that's a lot of noise and a lot of heat going on just to push something, to make something go around in a circle so that our wheels can go round and round. Now, if you've ever touched the hood of a car after you've been driving for a while, you know that there's a lot of heat involved. There's a lot of noise involved in a car. If you've ever been in a regular car and then gone into one of those hybrids that's working on electricity, wow, there's like no noise there. So energy efficient cars have come a long way in trying to use their fuel better, not have a lot of energy wasted in other things, and really come a long way. And it's only been recently, in the last 10 years or so, that those kind of cars have become affordable enough that the public can start using it, because that did not happen when I was your age. There are other ways that technology is improving to get more energy out of the resources that we have. For example, solar cells. Solar cells, they have chemicals in them, and that collects and stores the electromagnetic energy from the sun, and then it translates that into electricity so that we can actually run our houses off of that. And it can very easily become electrical energy, and it's been just recently, again in the last, I think, 20 years, that it's become even affordable. This technology was out probably 50 years ago, but it was so expensive to make these solar cells, and it's now a lot less expensive, and so a lot more people are starting to use that, put it on your house, and that's where you get a lot of your electricity. You don't have to pay for it from anything else. Wind turbines and windmills are another great source of using the energy that's already around us and helping harness that to make electricity that we can use, because the round and round of a turbine or a windmill turns the turbine in the generator, which makes electricity. You do that with paddle wheels as well. As water flows over it, it spins it, which spins the turbine, which in the generator, which makes electricity. So there are a lot of different ways that we're trying to get energy and not be so dependent on fossil fuels. We have a lot of renewable energy. Wind and sunlight and water flowing. Now granted, each of them has their drawbacks. Windmills chop up birds, and paddle wheels and stuff chop up fish and stuff like that. So yeah, there are environmental things that we have to think about, but they're renewable. The fossil fuels that we use are getting used up, and so we are now dependent on foreign oil, and you hear that a lot in the news. And essentially what that means is there are other people who have a lot more oil than we do, and we spend so much money buying their oil to make our gasoline to feed our cars and our generators that but we're using it up. And because we're using it up, it's getting more and more and more expensive. And so if we could become less dependent on foreign oil and come up with different ways to come up with our own energy, renewable energy, energy that doesn't get used up. I mean, you know, you can cut down a lot of wood and make a lot of fires to make a lot of heat to generate enough energy to make electricity, that kind of thing, yes. But then you have to replant those so you can reuse them. And yeah, that can happen, but how long does it take to grow a tree, you know? Water, wind, biomass fuels, that's trash. That's like a compost pile, using the energy that's in our trash to create enough heat to turn the turbines that make the generators, create electricity. That would be really cool. Geothermal energy is something that the Earth naturally creates, and there are spots on the surface of the planet that are a lot hotter than others because the crust is thinner. If we could harness that heat, and a lot of countries have, I'm not going to come up with the name, but I will find it for you, that they've got natural like hot springs, but like on a large scale, and they've started using that energy to help them with their energy needs. Hydrogen. We got hydrogen everywhere. It's the most abundant element on the planet, in the universe, but on the planet is actually accessible. And we can actually do a lot with hydrogen if we can figure out ways to harness it and get it to be useful too. There are a lot of hydrogen cars and things right now. So it's an interesting field to be in. And so keep your eye on it. Anyway, ta-da, we're done. Come back tomorrow ready for a clicker quiz, and I hope you are having a lovely evening. Take care. Thanks.